everyone, and welcome to yet another exciting initiative by MIT ID Innovation. We are very pleased to share our open online courses focusing on innovation essentials have been launched this quarter. The duration of these certificate courses range from 1 month to 9 months, in addition to our full-time one-year campus-based course. Do visit our website for more details on the same. We now welcome our guest faculty, Mr. Nikhil Joshi, Vice President and Head of Experience and Intelligence Practice at Entity Data. He is an industry leader with 25 years of work experience who started out as a software engineer in the manufacturing industry and now leads enterprise mobility and modern web development, enterprise content management, and data and intelligence practices with a charter to drive business growth and innovation in his current role as Vice President and Head of Experience and Intelligence Practice at Entity Data. An accomplished senior technology executive, enabling digital transformation to drive immediate business outcomes for enterprises while preparing for the future. He is a seasoned global leader with successful complex business transformation, M&A related integration, and program implementation experience. Close to 14 years was spent at Capgemini, Pune, where he started out as an IT strategy consultant, moving on to a client partner role, then eventually as a practice head, leading the financial services division for Capgemini's QA and testing practice in North America. He managed over $120 million US in annual revenue and led a global team of over 2,000 highly skilled QA and test professionals. He is an alumnus of Visvesvaraya National Institute of Technology, GIES College of Business, University of Illinois Urbana-Champaign, Northwestern University. This curated series will feature a variety of industry thought leaders who are now a part of the global MIT ID innovation ecosystem. We now welcome Mr. Nikhil.
Hi, thank you so much for the introduction, and it's great to have everyone here. This is going to be a great ride, I promise you. I'm really privileged to have been approached by MIT ID Innovation along with Nordic Mojo to have these series of sessions where I share some of my experience, some of my learnings, and impart with all of you. This has been, as I said, an exciting journey over the last 25 years in multiple roles across the globe. So as we go through this, you will see glimpses of what I have learned personally, what I've seen as some of the challenges that are there in the industry right now. And we'll also go through what we can do to get ahead of the curve. So let me start off by talking about the course, and I'll open my presentation. So we'll walk through that a little bit and see this. So the course name, what we have is data-driven decisions. And as you can imagine, this is all about, how do we use data, which is such a fundamental thing, and understand the tools to accomplish, fundamental tasks. And it's really about, as business managers, as business leaders, how can we use the information around us to arrive at conclusions in not just an intuitive way, but in a scientific way as well. So we will employ some technologies and techniques to go through this process. And I think you will all enjoy the interaction that we will have, the experience that I will share. We will talk through multiple different aspects of data analytics, starting from some fundamentals around data science, exploratory data analysis, classical statistical modeling, machine learning models, visualization and insights, and then ending with artificial intelligence and decisioning, including automation. And that's, again, just a quick glimpse into this world. Please be cognizant of the fact that this is something which which has been there for some time, and it takes years for people to learn. So what what I'll be sharing and what we'll be learning together will be a sliver, a small slice of this giant body of work that exists today. This literally thousands, hundreds of thousands of people who are actually working in this domain today. But we all can learn and contribute in our best meaningful way if we understand these fundamentals. So we'll go through that in a little bit and try to understand what this really means. So let's talk about the first one, which is really data science fundamentals. And this is where, if you look at data science as a topic itself, it is pretty unique, and it has evolved over some time. And as you can see this chart on the slide, it's really a combination of three fundamental aspects that exist, which come together. The first one is good knowledge of mathematics and statistics, which I think everybody should have. And again, don't worry, we're not going into elaborate calculus-based exercises, but really something which is fundamental. And I think when we talk about some numbers, some common metrics and all that, you will immediately realize what we're doing. Then it comes to the industry or the domain expertise, which is a specific industry knowledge that we all have. And as we go through this process, you'll learn how we apply that. Some of us have more knowledge in one particular area than the other, but in general, understanding how the business works, understanding how business processes work, understanding how the market works is important for us to apply some of these concepts that we learn here. And then last but not the least, knowing how to program, understanding how the computer crunches these numbers is also critically important. So when these three things come together is when you will really see data science sort of really come alive. Right? Through machine learning, which is really a combination of the knowledge of computer science applied to math, through software applications that are driven through understanding of computer knowledge, as well as industry domain, and then looking at what is relevant from a data standpoint is how we will be able to combine this all together. We see data science and the application of data science around us all the time. And if you look at, for example, when we are switching on the TV, you look at weather forecasts, and the fact that we are able to confidently say what's going to happen in the next 10 days is all because of data science, because people have taken this information together over the last several years, built these complex models which incorporate different parameters, are able to predict what is the weather going to be, is essentially because of data science. We use this today every day when we're doing shopping, online on Amazon or Flipkart or other, online places, where as soon as we log in with our IDs, the system that tells us what are we going to buy next, and or what do we need to buy when we select an item, what are the other choices. All of this is essentially enabled by the application of data science in this particular world. And the use cases, just a couple of them on this list just keep on increasing. That there's no limit to what we see. And our world, essentially the way we are seeing the world today, the way we interact is enabled solely because of this massive number crunching that happens in the back, and allows us to really be smarter about things, right? Which enhances our intelligence and gives us the tools necessary to carry out our tasks. So we'll learn these basics in those 2 hours. We'll have a very exciting session where we'll walk through some of these fundamentals. We'll talk through what is being used, go a little bit in detail, see what it really means. What are those programs really doing there? Then we'll follow this up with going in a little detail around some of these technologies or methods, I would say. And the first method or approach that we use for analytics is what we call as exploratory data analysis. And that's something which is well known in the industry as well, but we'll give you a glimpse of how to do this. What are the ways you can collect this data? What are the different types of data that can be collected? And then starting to apply some of the technology, some of the techniques that we know. For example, how do we group them together? What are some of the central tendencies that we see of this data itself? How is this data distributed? Right? What is the dispersion? What is the mean? What is the standard deviation? We look at some of the different ways to visualize this data. So different graphs and different charts, we'll talk about that. What do they mean? And then finally, we'll talk about also what do we infer from this? What do we conclude from this data set that we'll talk about? And all of this stuff is essentially meant for us to quickly apply to a set of data available. We are not going to rely on complicated methods and programs and software to do it. Some of that, yes, you will need some basic software, but we will essentially take a very simple elementary data set and then try to apply it to make meaningful sense of it. And we will use examples that we talked through earlier to get this. We can talk about the stock market, some of the trends there. We can talk about what is currently going on with COVID, such a big part of our lives right now. There is a tremendous amount of number crunching that has gone on, trust me. And we'll refer to this topic a few times during this course as well. And hopefully, as we have these lessons, some of this, importance will still be there. We are not out of it yet, but hopefully people would have gotten vaccinated and so on. So we would have seen some letdown of the things around us. But even then, it's so prominent. And we'll talk about some of the data elements that are giving us additional insight and knowledge, and essentially enabling our governments or regional bodies to make decisions based on data, right? Based on science. So essentially that's really what we will talk through. We'll take some examples and we will see each of these sort of different aspects of the exploratory data analysis being applied to those aspects, and how do they really come together. And you will trust me, when we go through this, you will get that aha moment where you say, okay, oh, all right, okay, I've seen this information. Now it makes sense. Now I understand how the different types of information were collected together, and I was able to really come up with this final answer. And that can be done very simplistically. Trust me, this is one of the most powerful tools that we will learn through the course of our session. Followed by, then we'll go a little deeper into applying. So when we say statistics, what does it mean? Yes, we talked about mean, mode, median earlier. We talked about standard deviation. We talked about some of those basic concepts that from a statistics standpoint. How do you use them? How do you create models? So he will talk about, essentially, he will start thinking about creating models which are nothing but representations of patterns. And when we say patterns, it's really the things that we see around us. When we see these things repeat themselves, when we see that, oh, all right, I thought I saw this thing happen earlier. So what does it mean? If it happens once, it happens twice, it happens 3 times, is it giving me a trend? What is a trend, right? And what are these, how can you predict information based on these trends? We have, we'll talk about some of these basic models, especially in statistics, around linear models or progression models or regression models, where you'll see the information as you put together, and that information come to life as we plot a relationship through these. And again, the most simple of these will be linear regression models, and then we'll talk about a little bit of more complex relationships, such as polynomials and curves and so on and so forth. But the point being, once you use statistics to build models, you will be able to then reliably predict an unknown information based on a known factor or a known parameter. And that's where you will see, again, how models are created. We'll talk through some of the different types of statistical modeling that we hear typically around us, around random variables. What do they mean? We'll talk about inferential statistics. How do we use this information? What does it mean if the mean weather in a particular place is so-and-so on a particular day, or so-and-so on a particular day of the year? What does it mean to the other days of the year? So we'll talk through some of these relationships between the metrics themselves. We'll talk through some different examples of descriptive statistics. What do they mean? And then what really is interesting between just pure statistics and the number crunching, to get into the little bit of intuition stage where we talk about probability, and we say, okay, how do I use the probability, right from the quintessential basic probability of doing a coin toss to actually doing something more elaborate, something more scientific with the information that we get. So we'll walk through this, and the intent of this session is to really allow you to get familiar with these terms, but also apply them simplistically to what we are learning. And this is critical, because as we walk through this course, as you will see, the progression is from understanding what is data science, understanding what is data, how to collect the information together, do some basic analysis, and now we're starting to get into sort of creating models which are more consistent and reusable. And that's sort of the flow that we are in. We're sort of in midway in that journey when we create these statistical models, and we'll talk through, as I said, different types of models and so on and so forth. And again, we were gradually applying the terminologies and jargon so that way you will learn through this process. So you will be able to talk through it intelligently, but we'll also learn with the help of practical examples. So I don't want you to essentially memorize formulae and so on. And that's not the intent in this activity at all. All of us are experienced people, and that's the last thing we need to know is to learn a few formulae. What you will learn, though, I promise, as you go through this, will be tools and techniques and applications of these models, creating these models to common, real, common day, everyday problems that face us every day, and essentially in the business around us. So once we have this, once we have the sort of basics accumulated, is when we get into a little bit more information and knowledge around machine learning. And when I say machine learning, trust me, this is not so much um, about what is machine learning, but really around the different models that exist around us. If you look at some of the different types of machine learning that exist, you have essentially the supervised machine learning models, and then you have unsupervised machine learning models. And then when you look at supervised machine learning models, you have the classification models around how do you differentiate data? How do you look at different analysis? We talked about regression, linear regression, and other polynomial regression models, and so on. How do we use that information to give us and predict and forecast other data, which is really supervised, because we are feeding in information, and that information is giving us results in the future. When it comes to unsupervised learning, now we're talking something, right? Now this is where it gets into the voodoo arts, and we say, what? How can the computer predict these things? That's where the models are built in a way which allow a distribution of this data. That's clustering essentially, and then looking at how do I reduce the complexity of the different dimensions or different parameters I assign to the data set, and then finally by employing techniques like deep learning, where you're really able to, as you can see in this chart as well, use multiple methods to really at the same time extract the information about the features, do the classification, and then give you the necessary conclusion together. The unsupervised learning also is critical. It takes time for us to truly grasp how it is done. It requires some fair amount of programming as well. But again, this is where there's a lot of software available. You don't need to type in code by yourselves, but it's important to know what are these different techniques so that way you're able to apply it. And again, I mean, the idea is for us to be able to find a way to interact with the information around us, right? How do we take the information around us and then essentially respond to that data and that information with a scientific frame of mind, which will make sure that our observations are understood, our conclusions are understood, and they're real. And that's kind of a reinforced learning process that happens through this again. And I don't want to give too much, but this is where we'll try to simplify this term. When we say machine learning, immediately everybody kind of raise their hackles of, okay, all right, so am I supposed to know computer programming? Am I supposed to know R? Am I supposed to know Python? The answer is yes and no, right? It depends on where do you want to apply this and how do you want to apply it. We'll talk about the different tools that are necessary for doing it, but there's modern software available which doesn't let you or doesn't need you to essentially do these things, to learn the basic bare bones. We'll talk about these techniques, but then we won't go through the learning the programming language itself, right? We'll talk through some of the software and how to use it and so on. And that, trust me, once you go through this process is when you will know enough about how a machine learning model is created, how that model can be maintained and managed, and then how that model can be used to give you meaningful information, right? So we kind of progressed from what was data. We talked about how do I just quickly analyze data and create some conclusions from that. And then we talked through some of the statistical models that we can apply. And now we are creating these models, using statistical models and building, real sort of assets which can be reused over and over. We go to a next level of, again, trying to make all of sense of all of this, right? Well, this is all happening behind the scene, right? But what is in front of the screen, what is in front of us is really visualization of this information. It's extremely important from a data science standpoint to have the output portrayed in front of us which makes sense. Whether it's a predictive model, whether it is just analysis of the past, right? You need to be able to show this, right? If we can't use it if it's only in your mind. It has to be on paper. It has to be on the screen. It has to be somewhere. So how do you visualize it? What are the different ways to visualize it? And trust me, we see this every day, right? You open a business news channel, you will see charts of the stock moving up and down. You will see news channels. You open CNN today. We talk about COVID or other things, which essentially tell you how the information can be processed and then portrayed in a way which is really going to tell you a story. And that's really what is key about this. So as you see on the left, the different types of visualization that exist. You can use charts, we can use tables, you can use multiple graphs, you can use maps to show this, and I'll talk to some examples. And then, of course, there's this newfangled, I would say, very fancy but very interesting and informative way of telling stories called infographics, which exists today as well, and we'll talk to some of that. And then finally, dashboards. You know, all of us executives, you know, you see these dashboards and different reports every day, so you see that information together too. What you see a picture on this right is essentially a snapshot of the current sort of COVID tracking system that CDC here in the US uses. And they have this information where they're collecting data runtime from all of the different states and putting together a very, very, very detailed analysis of how the disease, how the pandemic is progressing, how the different initiatives around vaccinations and so on are going on, which allow people to take quick action, and not just individuals like you and me, but also decision makers in the government, in corporates, and so on, where they can say, how do I take this action? What do I know? When do I know it is safe? Trust me. And it's not just restricted to the data, around whether I can go and, watch a movie in the theater or not, but it's basic information around whether it's safe for me to travel in a particular place. Our company and my team has worked on building algorithms that allow you to predict the number of people who are going to be in a train. We work with one of the largest public transport systems in the world in the state of Victoria in Australia. And we've built together this fantastic algorithm that allows us to predict this information on a runtime basis, where before boarding the train, before entering the station, you can know which trains will be occupied and how much, and that can, this kind of insight is tremendous, right? And it's again visual. You need to see it to believe it. And there's just no dearth of this. Now, here's where, again, some of these technologies there's some, we will rely heavily on software in this case. It's very hard to plot some of these graphs by hand. You can definitely do maps very easily there. And I will talk to some historical examples where people have done this through the ages, even before computers existed, in the 1600s and 1700s, even before that, where they have actually plotted the information and based on the data that they had to give you a sense of what was going on, and that's available, and we'll talk through that as well. But especially after the advent of computers, this information, this particular field has just ballooned so much. There's so many organizations who do that, and we have seen this in the technology world. Different companies like Business Objects and Cognos and Tableau and Power BI and so on and so forth taking forth, and now really ruling the roost here. They're very, very smart way of doing it. So we'll talk about some of these tools and technologies also that are used in the industry primarily, where this information is collected, processed, again, and then portrayed or visualized in a way that will tell a story, will show a result, will enable people to make decisions. But that's, at the end of the day, that's what you really want. It's not just a pretty picture. Oh yeah, you don't want to just do oohs and ahs of beautiful fonts and colors used here. You want to take this information and say, okay, all right, what does it make sense? What does make sense from this? And then how can I use this knowledge to make a decision that will benefit me and my organization in a very direct, in a very material way? And that's what we'll talk through from a visualization standpoint. Also, insights are all to do with this information that you see together, and then it's like imagine as you're driving a car, we rely heavily on what we see in front of us, which is through the windscreen, and then what's behind us, which is what we see through our rearview mirror. And that's exactly how we should be driving, our businesses and our work as well, where you're able to see based on data, right? What is happening behind you, or what has happened in the past, which tells you what you need to do in the future. And if you don't have that 360-degree view, we're not going to be very successful. So that's what visualization and insight will essentially enable you to do as well. And then lastly, we will walk through essentially taking information, all of this stuff that we have learned, right? Data modeling, we talked about data science, statistical models, machine learning, and now we talked about the different visualizations and insights. What does it mean? Why do we want to learn this? Is it just for my decision making? What if I, don't feel well a particular day, or I'm not able to make the right conclusion, or I don't want to be a decision maker every day, right? Can I automate this process? So that's where, all of this knowledge, all of the information that we put together comes to great use, because we, go through this process of saying, what is my, the different information that I collect together, how do I piece it well, and then understand through capturing my business objectives, looking at my business processes, I modify my business process, and then automate some of that. And then ultimately, I'm looking for operations that are intelligent to act by themselves. And let me give you some examples as we walk through this, especially in the financial sector. Imagine when you are processing loans, and I'm again not talking about lakhs and crores of loans, but simple basic lending technologies where I'm saying, oh, I want to buy something but I don't have money right now. How do I determine if I'm worthy to be given the loan to, right? And that worthiness can be determined quickly by taking all the information about me in the past and processing it, and then the computer tells me a particular decision in a split second by looking at my credit history and so on. That decision making is essentially what we're talking about automation. So sometimes all of these things happen behind our back. The basic fact that when you swipe a credit card in an ATM machine, and they say, okay, all right, authorization or approved, means that somebody has done this thinking, this validation in the back end, and has automated this process to actually allow you a credit for that purchase. Again, all of this is transparent to you, but this is a business process that has been automated. Now, you can imagine taking that business process automated to a different scale. We're talking about mortgage loans. We're talking about medical treatment. We're talking about some of these have to be regulated through government regulations to make sure that these automations don't essentially take over and give you wrong results. So they have to be inspected, they have to be validated, there has to be quality control on that. But it's basically that automation of the process what enables a good, successful, automated decision is what we have learned in the past. All of the stuff that we talked about, data decisions, about data science, about statistical models, all of that has enabled creating this particular automated process. And we'll walk through some examples where we will construct this automated journey right throughout. There is a lot of technology, a lot of improvement on this. We have, insurance sector has, tremendously ballooned, especially in the US and elsewhere in the world, where you can file a claim by just taking a few pictures of the car on your phone, and then immediately get the result from your insurance company what next steps they need to follow if you need to buy a new car or whatever. The whole purchase process we talked about has been automated. This is multiple domains that have been covered because of this. And then of course we see this on the shop floor as well. And around us, even agriculture has been favorably affected by this with, especially in the US, automated machines doing all the farming by themselves. How does that happen? And what is the process that happens behind the scene to enable this? And we'll talk through some of these examples and these techniques. Again, the intent is to introduce you that this thing exists, sort of open the kimono a bit, maybe give you a view into how the sausage gets created, so that way you can see for yourself. It's not, it's not a completely rocket science in the sense, because of the things that we have learned in the past, we are able to put these different pieces together and make sense of that entire journey. So we can confidently state, hey, this works. And I can build something like this for my company and save me a lot of time, save my company a lot of time, eventually save the people around us and the society around us, and improve that in general the well-being. And that's really sort of the last stage of this process, of this journey of learning all around data driven decisions. So trust me, this is going to be fun. As I said, I'm going to use a lot of my experience, a lot of my knowledge. I'm going to use a lot of the tools and techniques available today, and we'll keep it interactive. I know this session has been mostly me talking to you, but trust me, this is not going to be like that. You're going to have a good amount of breaks. I definitely want conversations to happen. All of us learn through experience and not just through a one-way process. So really, really excited to do this in a couple of months and share my knowledge, my experience with all of you. Thank you.
Thank you so much, Mr. Joshi. I think you've taken a lot of time and effort to actually put together all these takeaways from your journey dealing with data. And I, at least for one, definitely envy you. And I'm sure many others will also. But you've kind of simplified data for so many of us. Thank you so much for that. So for any questions that the audience may have, we request them to reach out to us offline on LinkedIn. And we do recognize the need to reach out to thousands of aspiring innovators and help them gain the skills and knowledge required for their dreams to become a reality. We encourage you to connect with us via our social channels. For those interested in becoming top-notch innovators, we invite you to explore our certificate courses that will fast-track your career path. So log on to www.mitidinnovation.com to kickstart your innovation journey with us. Thank you once again, Mr. Joshi. And to everyone, stay connected, stay safe, and please keep innovating every day. Let's learn, innovate, lead.
My pleasure. Thanks a lot.